How are you guys? Welcome back to my YouTube channel. Today we're still under the pumps, right? We're still under the pump, reciprocating pump. This is fluid N6. Today we'll deal with the effect. Let us check the effect of acceleration on suction side. The effect of acceleration. The effect of acceleration on suction side. Right. Previously we saw how the diagram became when there were no effect. We do not consider effect of acceleration and friction, right? Now we'll consider the effect of acceleration only, not we won't include the friction. Now acceleration is, we know that is given by h, let you write a like this. Friction, accelerating head, if when they say, we know this will be given by little l over, right? That is a little l, right? Then we're calculating the accelerating, right? So when you consider that accelerating head, must know that is a little, you want a small capital letter L, right? And then this small capital letter L must be what? Must be the length. Suction must be suction length. Must be a suction length. Must be a suction length, right? This must be a suction length, right? Over G, which is gravity. Multiplied this formula, multiplied by d squared over d squared, in actual fact. Or you can say, actually, let me just say multiply by area over small a over area. Let me show s there, little. Let me show little s here to indicate that this length, or we're dealing with suction. Okay, let me just do like this. Okay, let me just do like this. The accelerating head is like this, right? Multiply it like this, right? It's fine. Now multiply by angular acceleration square, right? Multiply by the r, right? This is our accelerating. This is our accelerating. That is our accelerating, right? So this is our accelerating. Fine. Now, since we are looking and still we are under suction side, that means this. That means since we are under the suction side, that means will be the area of what? Of the suction, and little let of the suction there. Then this can be ls over g multiplied by d squared over d squared multiplied by w squared multiplied by r, right? That is it. Right, this is the formula. This is the formula for accelerating head, right? So you must know that the vacuum will occur if the vacuum will occur when a vacuum in the vacuum will occur when the suction head vacuum will occur when the suction head plus accelerating head will be the sum of suction head plus the accelerating head. If the two occurs when the sum of the two, then will cause what? A vacuum. There will be vacuum. The negative pressure, the vacuum will take place here. This is our vacuum. Is HS plus HA, the suction head plus accelerating head. This will result with the vacuum. So let us split our diagram like this. You can also multiply by cos theta if you want, but let us erase this cos theta then for this moment. All right, we know here is cos is theta right here. The x-axis we have theta, here we have absolute zero. Then here we have pressure, right? In that direction, therefore in that direction we have theta, that direction. Here we have pressure. Here it's zero. Increase. Here we have this point here is zero. Here would be 90. Let's say here we have 180 degree, 180. This point, right? Then here we'll have what? An atmosphere, or H. An atmosphere. Remember, from here until there supposed to be what? HS is a suction, right? It's a suction. Remember, diagram must be like this. When we have two, from here until here must be HS. From there until here somewhere must be H delivery. Right. Today we're focusing on the suction side. This is the suction side. Then above the atmospheric we have what? The delivery side. Below the atmospheric we have what? The suction. Here, this is the suction. Below the atmospheric line here. Let me just do like this. This is our diagram here. Alright, so let us check the effect. Firstly, we know that we'll start here. We'll go when the pressure is below the atmospheric. This will decrease until somewhere here and move straight. We'll take and move like this. Let me erase this until until 180 here. then silently will increase. This occur when there is no effect. When there is no effect of what? Don't consider acceleration. But now we consider the effect of acceleration, right? When there is a when effect of acceleration occur, we'll have this will decrease a bit here. Let me write like this from here. Right, when there's no right from this point till here, we'll consider the effect of acceleration. And when you consider the effect of acceleration, we'll have right. Wanna consider the effect of accelerating, we'll have from 90, let me we'll have this, and also that side from here till there, we have something like this. Let me draw straight. It to be something like this. Right, something like this will be something like this, whereby from here until here we have H suction from there until there. This will be the accelerating head. Right, we'll have an acceleration head on the suction HS, accelerating head, accelerating on suction pipe. Before the water will be just before the water being sucked up, we will require an acceleration initial from the beginning of the suction. From the beginning of the suction, will require an acceleration and accelerating to take place, which will be acceleration at what? At the suction side, right? Will require that stuff, right? You understand what it is? That is what we will require. We know this will be what our diagram, and the area will form something like a the area from this that will form something like a trapezium, but like triangle trapezium. Okay, the area here will form something like a trapezium. This one, the vector under this area will be structure like a trapezium. See, our section will be something like a trapezium. Before, let's say we have a dam. If you have a dam, we have a pipe there that is a suction pipe. You will need to suck up this water. You will need what? It will be required at the start as accelerating at the suction. You will need accelerating just before at the start and also there at the end, So that means this is actually on the suction side. If we consider again if we consider this was the suction side, right? If we consider again delivery side will be a mirror of this. That means you will just draw this at the top. You take this structure as it is, you draw the structure here at the top. If we consider, here we're considering the section side, then we'll also consider we'll consider the delivery side. Now we're still considering the section side. In the section side, this is how the diagram, the indicating diagram will look like. Right. Thank you. Don't forget to subscribe. Stay notified as I'm posting some new videos.